Alright.
Hi, camera.
Can't see you. Okay. So we're going to talk about, this whole chapter is about measurements, being able to accurately measure things, use correct units, use correct converting from one thing to another. We'll do lots of unit conversions in this chapter. Going from one unit to the next, it's actually very, very important in science. And I'm going to make you do it a specific way so that you're more equipped for college and more equipped for my later classes. But that's not today. Chapter 3, measurements. Okay, so we're going to talk about measuring and how we measure and what numbers we use to measure. Where's Moira?
She's dead. She's dead.
Oh,
wow.
It's a Monday?
Yeah. Fine. Slightly. It's like teriyaki chicken or Sesame Street.
That's Elmo's logo.
I'm all covered in Scarlet.
Anybody else on or just Moira? Alright. Good. Why don't we need a measuring? Why do you have a measure? What's the point of it? What do we need it for? Yeah, it's a little deeper than that. Don't know about the universe. You can't measure anything. How are you going to learn anything about the universe? That would be a problem. You wanting to know the distance between Des Moines and Kansas City?
Oh, it's 3 hours. I just went there.
3 hours. Well, how fast were you traveling?
Well, my dad drives like that.
Nice. Is your dad a pastor or something? So, I drive. I haven't got a speeding ticket ever.
It's even better because we had like all
Nice. Alright. So, very first thing, it helps us understand and learn about the universe. We can't measure things. We're really going to be pretty stunted in our ability to learn things about the universe. Okay, give me an example of how measuring something could help others. Sure. Yeah, you wouldn't want them to get squished in the hole. Okay, any others? Go ahead.
Measuring space in a room to find out what size of stuff you can put in there.
Or like fire code, right? How many people should be in here safely so that, you know, when the fire bell goes off, we don't all cram and trample each other when we're trying to get off, you know, in our little mosh pit. You got one?
somebody's saying you want to make sure you have the right one.
Yes, that is a big one. For example, as you guys know, Tylenol is a drug that its actual name is called acetaminophen, is what Tylenol is. And it's a really, really complicated chemical. Wish I could find it. Like, let me pull that up since we probably have time. There's time.
There's always time for Tylenol. We'll give up our lunchtime to play Tylenol.
I won't.
No, because they're sea socks, so. Well, I
Wait,
sea
what
socks.
is
Alright, so that's what acetaminophen looks like. And I know you probably don't know what that means. That's like code language. You'll do some of that later on this year when we draw structures of certain things. Not that complicated. We won't do little rings or anything like that. But if you take acetaminophen and you take a mirror image of it and form a structure of this mirror image, same stuff, same looking structure, just the opposite, it'll kill you. No, like if you had the same amount of stuff that makes up acetaminophen, but you structured it the opposite form as what it is, like mirror image, okay, it'll kill you. So, you know, being able to measure those things right and being able to measure things is pretty important. Right? Like, you're like, you know, this person broke his leg. We need to give him some, you know, really, really strong drugs for the pain. And then you measure 400 gallons instead of 4 milliliters.
Well, that's.
Like, that would be a problem, right? Pretty sure they would die pretty quickly. So it's very important that measurements are vital for being able to take care of people and not kill people. Last thing, to glorify God by helping subdue the earth. Take care of God's earth. If, you know, lightning struck and struck down a whole bunch of trees and wind blew over a whole bunch of trees and we just left it there and, you know, didn't bring in these big objects that lifted these, that we had to make sure we had the right measurements and took care of things. If we don't take care of God's earth, we're not really glorifying God. Okay, so we need to be good stewards. You guys heard that fancy word, be good stewards. What was that?
We're like in a chapter.
In the Bible. What is stewardship then, since you guys are doing that in the Bible?
Taking care of another person's property.
Or stuff, yeah. Taking care of someone else's stuff. If I give you something, I want you to be good stewards of it. So God allowed us to use His universe and His world, and we should really take care of it because it's not really ours, is it? We didn't create it, it's not ours. Okay? Alright, measurement. Let's define it without looking at your vocab sheet. Who can give me their own definition of measurement? We use measurements all the time, talk about measurements. Can we define it? Everybody? That would be doing a measurement, but how would you define a measurement? Like a measurement would be used to find the length of something, but how do we define the act of measuring? Yeah, okay, calculating is involved. Okay, calculating physical. How do we do that though? How do we calculate the physical property of something? Hey, this is not an easy definition. Once I show it to you, you'll be like, oh, okay, that makes sense. Okay, here's what measurement is. I don't know if I'll have it word for word, but I have it pretty close. It's the act of comparing an unknown quantity to a standard known quantity.
Measurements. Unit of measurement.
Unit of measurement,
You
okay?
can't use the word measurement in the definition.
Yeah, I know.
Measurement.
Sure.
Use the word color.
Okay, anyway. See what I just said? It's comparing something you don't know to something you know. It's essentially what a measurement is. When you take and measure distance in feet, you compare something that you don't know the measurement of to something you know. So everything that we do when it comes to measuring, we're comparing something we don't know to some standard thing that we do know. Did you guys know that all the standard units that we compare things to, people just made up? Like a foot for the longest time was literally just the size of your foot. Well, that's not the case anymore. We've come up with a standard that we said a foot is this long or whatever. I don't know. That long? Okay? Okay? So all of the units have been man-made. A milliliter, someone said this much volume is a milliliter. Okay? For example, I'm gonna make up my own unit. How about that? I'm gonna call it the Kramer. How about that?
Yeah, I
Okay.
saw that on the test. Like the ABCD and 20 was like the Kramer thing.
Okay, the Kramer. This is my standard unit. It's the length of 2 expo markers. Could I now measure Stephen and Kramer's? I could. Because I'm taking an unknown height or length and comparing it to a known standard. I just made up my own standard. You go home and tell your parents, yeah, we measured Stephen and Kramer's. Not a whole lot of Kramers. Okay? Alright, but I could make up my own standard as long as I know what that standard is. Could you compare it to something and it be tangible, and if someone else knew what a Kramer was, would it make sense to them? If they knew what a Kramer was, they would at least be like, oh, okay, I kind of know how big that would be, right? But now, since you know, if I go to 8th period and start talking about the Kramer, and I told them what the standard of a Kramer was, would they have a hard time with it?
Yeah.
Yes. Okay. So really, all measurements are comparing something we don't know to some standard unit that someone had created that we all agree upon and we're good with. Another thing that's important for a measurement when you're comparing it to a standard, that standard has to be constant. Like, it can't be a changing standard. You can't be like, I'm comparing the length based on the tide of the water. Because the tides of water go up and down. Right? You can't compare something to something that has the ability to change, like the size of our feet. Okay? But an expo marker, that's pretty standard, right? That's not gonna. As long as I'm specifically talking about an expo marker, not some other brand that might be longer or shorter. Okay? Instruments. I'll just have to get this in and then we'll talk about it. But an instrument is really this. Our senses are limited. So we need something to help it out. Okay. Instrument says this is a device used to help our senses when measuring. So give me an example where our senses aren't adequate enough to measure correctly. Yeah. Like if I were to grab Ethan and hold him in my hand, which I had, you know, maybe I could maybe hold him up, but maybe not like in my hand. Okay, would I be able to tell, like, I just bear hug him, lift him up, I'm like, oh, yeah, 108 pounds. See, would you be able to do that? No, you wouldn't be able to do that. So instead, what do? Use a measuring tool, what would we probably use? Yeah, a scale, right? I pick them up and plop them on a scale and call it good. Also, when I'm like looking at how tall Ethan is, can I just look at him and go, oh yeah, 5'3". Is it close? See, I'm proving why we need instruments here right now. You're 5'4", is that what you said?
Like 5.
Okay. All right. You don't even know how tall you are? Okay.
No.
I guess, yeah, I don't really either. I mean, I know how tall I am because I haven't changed in a long time. But, okay. If I looked at this desk, I'd go, yep, there's about 4 times 10 to the 75th atoms of particles in that particular desk. Can't do it, can I? Okay, but we have instruments that can do that. Okay, so not that. Yeah, we just have instruments that help us when measuring. Okay, it's really important that instrument must know the standard. Okay, your instrument's still comparing it to a standard. Right? Another thing, instrument must be calibrated, aka it needs to have like spaced out marks. Essentially what that means is, here's an instrument. This is a foot, I think. Yeah, a foot. Okay? Notice all the little tick marks on it? So it breaks a foot down into more specific or more precise measurements so that if I don't land right on a foot, like if I'm short of a foot, I can make some sense into that. That make sense? Okay? So that's what calibrated means. And I break it up into smaller units so if I don't land perfectly on a foot, I know what that distance is. Okay? Where'd you get that? Right, two types of data or data, however you say it. Who's a data person? Who's a data person? I will switch it. I will switch it off and on. Like I sometimes will say data, sometimes I'll say data. I'm a both. Here's two vocab words for you, and these are two vocab words that are going to keep coming back. This is the first time you probably have heard them, or at least put them in your notes. You may have heard a couple of them before. But you'll see them in future tests as well. What you doing, Jane? I don't care if you can listen while doodling. No one's good at multitasking. No one can do two things 100% accurate at the same time. Well, yeah, I can walk and open my mouth at the same time. That's different than two processes like reading and listening to somebody else. You know, watch a movie and be engaged completely in a movie while, yeah, like you'll get bits and pieces of both, but you will not be 100% engaged in both. Now, if it's subconscious, like walking and talking, like that's different. But you trained your brain to be able to do that.
But you're still having
You're still struggling.
as you go in circles. I don't know why, but I can't.
Oh, I don't remember I got it.
Oh.
That was easy.
You know, probably not. This?
What is go forward, go back?
Forward, backwards.
Yeah.
That's weird.
I got it. Wait.
It's going like.
Yeah, that's weird. Okay. Quantitative, qualitative. Everyone listen? Here's the difference. The beginning part.
Wow, that's
Qualit, quant. Which one maybe sounds like something you've heard before? Like qualit or quant? What is quant referring to?
a lot.
Quantity. You've heard that word before?
Yeah.
Which is amount of something. Okay, so here's really the main difference. Quantitative data always has some sort of number with it. Now, does this count for quantitative? Two colors? No, that's not the same thing. Okay? Got some number with 3 feet, 25 miles per hour, you name it. Quantity, it's some amount. Well, actually, two colors might be both. Yeah, two colors would be both. Yeah. Two colors would be both. I won't put a both one on a quiz or a test. Okay? But qualitative is not, no numbers here. It's a way of describing something. Okay? Mr. Kramer is larger than Ethan. Don't be offended by that. I don't mean any offense. It's just true. Okay? I mean, it is. No one argues that. If I say his ruler's red, Does that have anything to do with any type of measurement or any type of number attached to that? It's a descriptive thing. So qualitative is descriptive, quantitative is numerical, as in a number goes with some particular, usually measurement. Okay, you could say increases, decreases. You could name a lot of different things. Okay? Feel pretty good about the difference between quantity, quantitative, and qualitative. Okay? Alright, and I'm going to elaborate on that. I think it's pretty straightforward. Alright, so important, and it's so what you do not do in math. I don't like math for this reason. Okay, I like math, but I don't like that math doesn't have units. Because very, 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 very rarely do you do math in real life without a unit. What does Iran 7 tell you? Iran 7 centimeters? Can you even run 7 centimeters? I mean, that's not impossible.
No, I'm pretty sure that's what 7
Yeah, probably more than 7 centimeters. And then where do you start from? The beginning of your foot? Bottom, back of your foot? How do you do that? Iran 7 cows? No. Around 7 feet. Around 7 miles. That might maybe. Around 7 yards. That's more my type of running. 7 yards. I can do that. Okay. I don't run to run for fun. If you want me to chase a frisbee, I'll run after that. If you want me to, go play some basketball, I'll run after a basketball or somebody who has it. But I don't just run for fun. That's not my kind of thing. Time? So, the point is, here's another thing that's important. Let's say I'm doing an experiment, and I want to share my experiment with somebody in Sweden. Let's say I just came with this really cool experiment, and the person in Sweden's like, hey, can you give me the procedure of how you did that so I can do that experiment? And I do it, and I do the experiment, and then he does it, and his house blows up. And he's like, what in the world? Why did my house blow up? And we come and we talk and we realize that when we were talking about the temperature needed to heat this object up to, I specifically just said 20 degrees. Well, I was thinking 20 degrees Fahrenheit, and he was thinking 20 degrees Celsius, and 20 degrees Celsius is quite a little bit more hotter than 20 degrees Fahrenheit. And just so happens that the chemical, if it gets much hotter, will blow up. See how the unit's important? Okay? How about this? Someone was like, yeah, you had a headache. What did you do to get rid of your headache? I took 2 pills. And then, someone else pops 2 pills of something he shouldn't have popped, and his head pops. You know what I mean? Right? All right, see, units are important. Very, very, very important. Every measurement must have a unit. If you do a math problem in my class and you do not put a unit on it, if you liked it then, you should have put a unit on it.
Oh my God.
You know that's funny in a stupid way.
Yeah.
You know, you're smiling. Yes.
So, the test that I saw the meme, and the question was, why does Saturn have rings on it? And the person put, because God liked it, so put a ring on it.
Clever. Alright, so the point here is, if you do not put a unit on an answer that is a math question on a test, and it has units in the math portion of it, and you do not put it, I will dock you. Okay? Because I don't want you killing somebody in the future. Okay? No bueno. The metric system. Haha. Oui, oui, from France. It's so funny. First established in France and was followed voluntarily by other countries except for America. Yes.
System from,
No. ME?
well,
Some-
that's not step two. Well, how do you spell it? Do you spell it like that?
It's
Yeah.
spelled differently. I think you're talking about the French speaking here. That's like the French
Systeme.
word. Yeah. The SI units, what they would call it. Sisteme International del Units. I don't know if that's how you say it. Unites.
Megan.
Do you guys know the metric system, or we're from America, so we don't really know metric very well? Meters is a metric, kilometer, centimeter, millimeter. What's nice about the metric? Why does everybody but us use it? Anyone know why the metric system is a preferred unit or measurement system? That doesn't surprise me that you don't know. Because it's base 10. What does that mean? Every unit is a multiple of 10 of each other.
So it's easy to calculate.
It's very easy to calculate. I can move a decimal. Versus if I'm trying to do inches and feet, I can't just simply move the decimal and get from inches to feet. But if I want to get from centimeters to meters, I can just move a decimal. Go and do it. Meters are 100, centimeters in a meter. Base 10, multiple of 10. There's 1,000 millimeters in a meter. There's 1,000 meters in a kilometer. Okay, multiples of 10, move a decimal, real nice. Okay, but in America, we don't use it because it's different than what we're used to. We don't like change here in America. We like to be comfortable. So B, I'll explain a little bit about this. It was adopted by most of the world in what they would call the SI units. That's essentially what even America uses from a scientific standpoint. So essentially they need to come together and they're like, well, I want to make sure when I say something that everyone knows we're using the metric system so that little Jimmy over in Sweden doesn't blow up his house. Okay? So they all came together, all the scientists around the world said, we need one system that we always use. And they decided to use the metric system as the type of system that everyone from a scientific standpoint uses. So we don't blow each other's houses up. Don't put this all in. I will not make you put this all in. Just for our fun enjoyment. Okay? Dimensions, that's what we're measuring. Okay? Unit, meter, base unit. The base unit. What's interesting is kilogram has a prefix. We'll talk about that in a little bit. Second, ampere, Kelvin, mole, all those different things. Now, we're only going to be really using a couple of these. These are just some examples. Okay? Temperature, current, things like that. Right? Now, there is one exception. I don't really want you to necessarily write this in. I just want you to know that this is the only unit that has a prefix, which I gave you the prefix table, didn't I? Pretty sure. Kilo is on there, right? Okay? That is a prefix, comes before. So if I'm talking about a kilogram, that'd be 1,000 grams. Okay? Gram is technically the base unit, but we use kilograms. The reason why we use kilograms is because gram is a really small amount. If I wanted to measure something in grams, I would have a lot of grams before I got a substantial amount. So we use kilograms. For example, if I want to measure your car in grams, base. We have a large amount of grams. We don't like to deal with big numbers, so they decided to use kilograms as the base unit for mass. Okay, metric prefix is still here. Already talked about how they're multiples of 10. And we add prefixes if we have a really large number we don't want, or if we have a really small number we don't want to deal with. Oh, I have more slides I have left. So that's pretty much the last one. Alright, so used when the base unit is too large. For example, I don't like dealing with the fact that I got 1,000,000 meters. That's too big of a number and it'd be cumbersome to write over and over and over again if I needed to write it. So we take and we put a prefix with it. Let's say we wanted to figure out how many kilometers this has. Which I know you guys won't be able to do this yet, but kilo is 10 to the third, which essentially means I need to move the decimal 3 spots. So I've got 1,000 kilometers. Or I could, don't worry, we don't have to do this yet, because we're going to do conversions here in a little bit, and I can do it in my head, and I'm not actually going to let you move the decimal. I'm going to make you do something else so that you're more successful later on in my later classes. Because you can't always move the decimal when you're converting units, only for the metric system. What if I wanted a gigameter? No, megameter. Mega is 10 to the 6, right? Okay? So 10 to the 6 means I move the decimal place 6 spots. 1, 2, 3, 4, 5, 6. It's got 1 megameter. That's a little bit easier for me to write, isn't it? Now, if you know what a megameter is, you're good. If you don't know what a megameter is, you got a problem. Okay, but is it easier to write 1 megameter or is it easier to write 1,000,000 meters? 1 megameter. Okay, you can do the same thing for a really small unit, like 2,000,000 millimeters. Okay? Alright. Last thing is this. This is important here. We will need this when we do conversions, which we're going to, I don't know if it's coming tomorrow that we're doing conversions. We're doing conversions really soon. Okay? Just quickly before you leave. Prefixes come before a base. So if I'm talking about the base unit gram, a gigagram, its unit would be big G, little g. If I'm talking about a gigameter, what would that be? If I'm talking about how about a centimeter? What would my unit be for centimeter? Little c. So these are capitals. Those are the only ones that are capitals. What about a kiloliter? Okay, these are prefixed. They have multiple letters. What if I just said I got a gram? Does that have a prefix with it? No. Okay, very important that we're able to distinguish between a prefixed unit and a not prefixed unit. Please.